Good afternoon, YouTube. So I just wanted to catch this diversion load running. So I have my simple code here running on the diversion load number 1, and you can see it's automatically kicked up to 5%, which is about 30 watts. So this is the whole house power, and there's 2 clamps, one on line 1, one on line 2. The way the code's written, if it drops below 25 watts total, then this thing will go up 5%. And that's what's happened here. Now 50 watts is the upper trigger, and you can see that it just turned this off. Basic logic here is if this goes below 25, I add diversion load. If it goes above 50, I take away the diversion load. So what we can do is take a look at the code here. I'm using the no longer supported PLEG, which is Program Logic Event Generator, on my VeraPlus home automation controller. And the main reason I'm using it is because it works and my old code was written in this. So I figure I'll just stick with what works until I get the logic running here. So these are the device triggers. So these are the things that trigger something to happen. I trigger if the whole house energy goes above 150. I trigger if it goes above 50, and if it goes below 25. So those are the ones I'm using in my diversion load. Here's the trigger below 25 watts. Here's the device. The whole house energy goes below 25. So anyway, that's what's called a trigger. So that's an event that happens. And then down here is my code that runs the diversion load. So here's the code that turns it on. If that trigger of below 25 watts happen and it's during the daytime, and then I'm not maxed out. So this P diversion load 1 is the current settings. That runs from 0 to 100. And then the idea is I just don't want to go over 100 because then weird things happen. That's turn on, and then here's turn up. So this isn't triggered by an event happening, but it's got its own little check here. So it says if the power on clamp number 1 is below 25, and then it's the same logic. If it's during the day and the setting isn't too high, you turn this condition true. If it goes above 50, I turn it down. If it goes above 150, I turn it off. So those are my basic conditions. These are what's called the logic actions. So this is what actually does something. Turn up, turn down, turn off. This is the condition, turn up diversion load 1. And then it just says take the diversion load 1 and set it to the current value plus 5%. Turn down diversion load is the same thing, except it says take the current value and subtract 5. So this is pretty simple. It doesn't do a whole lot here. So I have turn on and turn off function, and then I have an increase and decrease function. So anyway, that's what the code does. This is what they call their status report. So I have the triggers here. So you can see they gives me the name of the trigger, and this is the current state. So these two here are true. We're below 50 watts and we're also below 75. I used to use 75 in my old system. And then here, clamp 2 is below 50 watts. I have the properties. So this is the way you basically read the values. You just say this variable P clamp 1 power is equal to that device and the energy metering value of that device. You've got clamp 1, clamp 2. There's the current value of the 2 diversion loads. So diversion load 1 is just the dimming setting, currently at 5. And that's the various conditions here. It tells you whether that condition is true or false. Not a lot there, but that's the status report. Oh, it looks like, yeah, so everything's shut off here. And I guess that was because the refrigerator turned on and drove the whole house power above 150 watts. So this turned off. So anyway, that's my basic code for controlling this diversion load 1 here. It's not terribly sophisticated, but it basically shows that it works. With this system, I have roughly 300 watts of grid tie power feeding into clamp 1. So actually right now the whole house is using about 430 watts. 300 of those watts are coming off of the grid tie system. So the net is only 128, 129. But when the refrigerator shuts off, this number could go negative. And that's the idea of this diversion load, is it can come in here and basically soak up 30 or 60 watts of power. I think the highest I've seen this go is maybe 15%. So it does the 5% from the initial trigger, and then it does maybe 2 more increments with the checking this power below 25 watts. So it's not really very sophisticated, but it does actually do the job, and it turns on when it's supposed to, and it turns off when it's supposed to, and it keeps the power in the range of 25 to 50 watts. And it'll sit here and cycle on and off during the day. So yeah, this is my Home Assistant screen. I've got Home Assistant running on my Synology NAS. But you can see here it's picked up these 3 devices, the home energy monitor for the whole house, and then clamp 1 and clamp 2 power. And so if we look at the power here, you can see overnight we're running 300 or 400 watts. There it's about 300 watts, and if the refrigerator's running it's about 400. And then you can see now during the morning here it's closer to 50 watts, 46, there 30, 40, 50. Yeah, right there, 1047, it was 21 watts. So that's about the time that the system kicks in. It'll keep going until maybe 2:30 or 3 in the afternoon. What I've done is I've run the diversion load up to 20%. So I put roughly 100, 120 watts of load on, and then I'll turn this off, and we can watch what happens here. So this should drop. We were at 96 watts. That should drop down. Yeah, and so we got this one to trigger because this one went below 25, so that triggered here. This one here didn't go below 25. It went back up from 27 to 45. You can play around with this load and then watch the system react to it. You have a little knob here. You know, I can turn the house power up and down with this slider and then watch what happens here and make sure it's doing the right thing. If you have any questions, post up in the comments section below. And in the next video, we'll look at diversion load 2. And it's handled a little bit different, so stay tuned for that video. And as always, thanks for watching.